Yes, so today in our today's class, let us understand the deletion, display and search operations. So in our previous video, we have studied about the basics of doubly linked list, its memory allocation and the insertion function. Here we will study about the delete, display, search operations. Yes, so how do we delete from first? To delete from first, it is very easy, students. We all know that the first is the pointer which will always point to the first node. We just, what we have to do is nothing but we need to take this first pointer and we need to move to its right. We need to move to its right. That, and we need to, when we do that, okay, first will be deleted. Okay, first pointer will be deleted and it will come to the, or it will point to the second node. Once we do that, students, we have to make the left of first as null. We need to make the left as first as null. Okay, so when we bring first to the its right, this particular connection will be deleted, whichever is shown there, shown in the display. Then when you make the first of left as null, even this pointer also will be deleted. Once we do that, once we do that, the first pointer which was pointing to the first node will come to the last node. Okay, yes, last means in this situation, in this case, it will come to the last node or the second node, to be very clear. But why do we take t here? We take t here because when we move the first pointer, the t is the one which will keep track of this data which is there in the deleted node, because we need to display that data which is 20 here later. That is why it will keep track of that. T will keep track of that. Okay, this is the basic concept. How do we exactly delete from front? Now let us see the code and let us understand it more clearly. Okay, so this is the delete front. Delete front is the function which is used to delete. Yeah, this is the user defined function, students. You can give your own name, let it be meaningful to the context. So here we are deleting from front, so it is very meaningful to the concept. Then we take one pointer t. This pointer t will take care of the deleted data. It take care of the deleted data which has to be displayed later, which has to be displayed later. Okay, so what we are supposed to do is say one case. Okay, that is if first is equal to null. When will this first happen? If list is empty. If list is empty, this will happen. Okay, so at that case, students, there is no element to delete, so that time just print the message, no element. You can just print this message. Okay, else. So we are more interested in this else case. Now we are more interested in this else case. So what we are supposed to do is nothing but we take t is equal to first. We take t is equal to first. Okay, so as shown in the example, students, let us draw one node here for your example. This is for our second case. Okay, for our case 2 where list is there. Okay, yes, so let me take only two elements for the simplicity. And we also know that, yeah, 20 was here, we know that 10 was here. Okay, so we know that it's a doubly linked list. There will be two connections. Okay, then yeah, this is the right link which will be pointing to the null, and we know that last is here, and we know that first is here, and uh, we know that our t is also here, because t is pointing to the first, which we shown here. T is equal to first. Okay, and we know that this pointer is also pointing to null, because always first in a doubly linked list, the left link of the first will always point to null, and the last link of the uh, that is the last link means the right link of the last pointer will always point to null. Okay, now students, we make t point to the first and we have to store the deleted data. Okay, so for that t we are making use of. Okay, and that deleted data, t of data, what we are doing is we are keeping it in t of data. So now this will store this data. Okay, next what we are doing is nothing but this is the main step, students, that is first is equal to first of r link. First is equal to first of r link. When you do that, first is equal to first of r link, this first which was here will come to here. Okay, so first and last both will pointing to the same node. Okay. Okay, so what we are supposed so when we do first is equal to first of link, the first which was there in the initial node will get deleted and it will go to the second node. Okay, yes, now there is a case, that is nothing but there is a case, what if first is equal to null. What is first is equal to null? So if first is equal to null, when will this happen? First is equal to null, this will happen only when, this will happen only when list is empty. This happen only when list is empty. If that is the case, students, that time simply do last is equal to null. That means only one node you had, that also you deleted. Okay, only one node you have. Okay, only one node was there before, node was there before. Okay, and now it's deleted. Now that is deleted. Okay, so that is the case. Okay, now that is deleted. Yes, so when first is equal to null, you also have to make last is equal to null. That means your list is empty. That is the list is empty. Okay, else what you're supposed to do is nothing but first of L link is equal to null. First of L link is equal to null. So students, we know that when we do first is equal to first of R link, what will happen is nothing but this particular connection will be removed, and when we do first of L link is equal to null, even this connection will be removed. So when both the connections will be removed, students, what will remain there? Nothing will but the null. So after deletion, deletion, this will look this way. So after deletion, it will look this way. Okay, this is after deletion. And we know that the first is pointing here, so we needed the data. What data was deleted? That is why we had taken t data. Okay, that is why we had taken keeps data of deleted node. Okay, so this is how we delete from front. This is how we delete from front. So let us go to the next concept. Delete from end. So students, what are we supposed to do here? Delete from end. So students, we know that already one list will be there. Okay, that time first will be pointing to the first node and last will be pointing to the last node. We need to take two node, basically two things there. That is nothing but we need yeah, when we are deleting from the end means we need to take one more node t. We need to bring t to the last position, wherever last is there. Then what we do is nothing but using t, we keep the data, we keep the data to be displayed whichever is deleted. Then we have to remove the last two connections whichever I have shown here. Okay, so when we do that, we get the last node. Okay, so here students, instead of first pointer which we were updating there, we need to update the last pointer. We need to update the last pointer. So let us see in detail how do we do this, that is deletion from the end. So this is our code of deleting from the end. So here also students, we use one user defined function. Here they have used it, user delete end, delete underscore end. Okay, don't put hyphen end, it will be meaningless. Okay, because in the names you cannot put hyphen, you can only put underscore. Next one, you have to take the node t, struct node star t. Okay, so t is of type node. Okay, variable of type node. Of type node. Okay, yes, now if last is equal to null, students, we know that if you don't have any element, then that means last will is equal to null, no element. Okay, list is empty. Okay, yes, so that's the set time you are supposed to do this. Okay, next is nothing but else what you are supposed to do it, you need to point t to the last, students. So say you have a list here. Okay, I have some data here 20. Okay, and I know that this is pointing to the null, and you also have some data here. Okay, and this is 10. Okay, now we know that by default this is first will be pointing here, last will be pointing here. So when I do last is equal to t, what will t also will point here. Okay, and we know that this is a null. Okay, now we know that our last that is whichever is marked in green, this particular node we need to delete. This particular node we need to delete. They're marked in green. So how do we do that? Okay, so that is nothing but, students, first keep the data of the last node whichever is deleted. So for that we need to do this message. We do print this message, that is deleted node is percentages t of data. When you do t of data, that in will be stored in t. Okay, yes. Next what you do is last is equal to last of link. Okay, last is equal to last of link. So students, what is nothing but, when we do last of last is equal to last of link, this last students, last which link you need. So you here two here, L is there, R is there. So when you do last is equal to last of link, last will last of L link they have given. Last is equal to last of L link. L link means it will move this side. You know, the last which was there here will come here now. Okay, now first and last will point to the same node, and this particular connection is gone, students, now. Okay, this connection is gone because you touched with the L link. Last is equal to last of L link, so that connection is gone. Okay, now students, what if last is equal to null? That means you don't have anything to delete. Okay, you don't have anything to delete. That means you had only one node before deletion. So in such cases, what is, you also have to make the first as null. Else, students, what you are supposed to do is last of R link you have to make it as null. So when you do last of R link is equal to null, students, even this particular connection will be removed and it will be pointing to the null, and it will also point to the null. So after deletion, this is the status. So after the deletion, this is the okay. So when we do last is equal to last of R link is equal to null, so we know that first and last are pointing here only now. So when we do this is a thing. So your second connection also will be deleted. So this is a situation after deletion. Situation or status of node after deletion. Okay, yes, so that is the deleting from end, the end. Okay, so let us go to the next this thing. Okay, so let us go to our new concept. Which is traverse, which is nothing but displaying in a doubly linked list. So this will not change much, students. Displaying in a doubly linked list is almost same as the displaying in the singly linked list. Okay, only the thing is nothing but, in singly linked list it is like you were going to the right of the node. I mean, you are going to just right of the node, but here you have to say check of the R link. You have to go to the right of the R link. Okay, so let us understand this. Let me have two nodes here, 20 and 10, and here we know that this is last and this is first. I know that left link of first is the pointing to null. Okay, now I need to display this. Okay, what I'm supposed to do is nothing but, I need to take one yes, first of all, yeah, let us go with the functions. Let us go with the flow. Yeah, so take one name. Okay, display user defined function. Then you need one variable called as count. This count will take care of number of nodes. Okay, total number of nodes to be displayed. Okay, to be displayed. Okay, yes. So initially, if you first is equal to null means, we know that always, students, if first is equal to null means you always your list is empty. If first is equal to null means list is empty. Okay, otherwise what you're supposed to do is nothing but, here you are taking a variable called as temp. You can take any variable, students. You are making temp point to the first. Make okay, temp point to first, because first's value you are giving to temp means what, you are making temp point to first, and initially count will be 1, students. Okay, initially count will be 1. Okay, so then what we have to do is nothing but, while temp is not is equal to null, that means till the temp reaches end, till temp reaches end. end. So who is going to traverse here? Temp will traverse. Okay, so temp will traverse through the list. Okay, yes. So while temp is not is equal to null, what you're supposed to do is nothing but you need to display, go on displaying the elements. So it is inside the while loop, so it will execute till end. Okay, execute till end of list. So here what I'm doing is nothing but when I do this temp of data, display data will be displayed. Data will be displayed. Okay, then what I'm doing is I need to move temp. Okay, move temp to its right. So here it is nothing but move temp to right. It's right. Okay, so students, look at the diagram now. Look at the diagram. Say initial temp will be here. Okay, initial temp will be here. So this is temp of right link, students. When I do temp move to its right link, once it displays this, okay, once it displays this, what the temp will do is nothing but temp will, after displaying, it will move here. After displaying, it will move here. So that time temp will point here next. Okay, for first it will display. So you are since you're doing printf here, it will be printed, data will be printed, and your temp you are moving, and you need to move the update the count, and you need to update the count. That time count will be 2 after reading one node. Okay, and the status of temp will be this, and the status of temp will be this. Okay, yes. And after that, once again when you come, what happens is nothing but now students temp, now temp is, if now you have to see whether temp is not is equal to null. Yes, it is not is equal to null. Now it will read the data. Okay, so it will read 10 now. Okay, first 20 was displayed, now 10 it will display. Okay, now next what it will do, temp will go to temp of null. Now temp will be null, students, remember, and count will be 3. Okay, next when it comes, this temp will be equal to null, and this particular loop will be I mean this, it will come out of this loop. Okay, now the question is a very important question. Count is 3, students, but we have only 2 nodes here. We have only 2 nodes, that is 20 and 10. That is why what we are doing is, to avoid that problem, because we are doing count minus 1. We are doing count minus 1 because initially we set count to 1. So that is why at the end we have to do count minus 1. So this is how we display through the doubly linked list. This is how we display through the doubly linked list. Next is nothing but search function. So how do we search? So students, as in the singly linked list, here also to search we need one key, for a key. So for that we are searching. So how do we exactly search? How do we exactly search? So again, let me take one doubly linked list for you here. Okay, so it has the element, and okay, like this, and let it be null. Okay, and we know that this will be first, this will be last. So now I have to take the key, students. Initially I need to read the key. Here read the key. Okay, this will enter key means print message, and here scanf %d and % means read key. So let me take key as 10. Okay, let me take key as 10. So what it will do is, first t is for traversal. Here t is equal to first means t will point to first, and it is used for traversal. Okay, so t will point to list, and t is used for traversal here. Like in the previous case when I was explaining you the display function, there the temp was used for traversal. Here t is used for traversal. So when we do this step, t will come here. Okay, t will also point here. Okay, next what we are doing is, while t is not is equal to null, like there we showed temp was not is equal to null. Here temp also you can use, students, but if you use temp in one place, everywhere you are supposed to use temp. So while t is not is equal to null, okay, what you are supposed to do is, you have to compare the key element with the t of data, current element in the t. Now what is the current element in the t? In first iteration, in first iteration it is 20. T of data is 20. So key which is nothing but 10, which is not is equal to 20. So this particular message will not print, it will go to else, and it will go to else, and it will do t is equal to t of r link. Now we know that t of r link is this, students. Yes, this is r link, we know, and this is l link. L link means left link, R link means right link. So when we do T of R link, t is equal to t of r link, t will point here, t will point here, t which was here, it will point here. Okay, next again it will come inside. So because we are not outside the loop still, t is not is equal to null, again it will come. So if key is if key is equal to t of data, it will check t bar of data. Now it is second iteration, students. Now it is second iteration. So know that in the second iteration it is 10. Okay, it is 10. So it is 10. So now it will check if key which is 10 is equal to key t of data. Now t of data, it is 10, students, because this is the data field. Okay, yes, so 10 is equal to 10. That means what? Search is successful. That means search is successful. Once it does, the students, it will come out. Okay, it will print and it will return. Return means come out of loop, come out of loop. So otherwise, students, it will again check till t becomes equal to null. If that case it happens, means it will not execute any if or else case. It will simply print search failed. Will print if both if and else fail. Okay, that means what? You don't have that element whichever you have searched, okay, in the doubly linked list. It is as simple as that. Okay, so this is about the search functionality. This is about the search functionality in the doubly linked list. So thank you, students. This is all we have in this video.